Hi guys, welcome to the Kitchen Think, a place where we share with you our thoughts, our ideas, and our commentaries on recent scientific discoveries in the fields of medicine, health, and fitness. Today's video, we want to address one common question from our viewers, and that is, how long is the COVID vaccine good for? How long does it protect me against a future infection by COVID-19? It's actually quite hard to answer the question directly, because if you really go back to the first people that received the vaccine outside of the clinical trials, that happened only about a month and a half ago. So we basically don't have sufficient data to answer the question directly. However, what we do have is actually patient data. So that's some information that I want to share with you today. So there have been a lot of studies that have covered this topic, but I want to focus on a recent one. This study is it's an ongoing study. So the scientists are following patients throughout time after they've been infected by COVID-19. And what they're doing when they're following them is taking some samples, serum samples, and measuring their immunity. So that way they can decipher or determine whether their immunity is long lasting. So I want to share with you that type of information. Now, the study had about 200 patients, not a big study, but a very important study based on the observations that they've seen. So they took the samples of these patients and they measured mainly three different immunity indicators, which I'm going to share with you today, among other things. The first thing they looked at is the ability of the patient to make antibody, how much antibody they produced, and how long they produced the antibody against the virus. So they saw that all the patients produced antibody, which is a good thing. Not only did they see that, but they actually saw that the antibody, although it dipped down a little bit throughout the time period that they looked at, it actually was still there at the end of, during this last update of their study. So this update was done 8 months after the onset of the virus infection. So 8 months later, they could still detect antibodies in basically 90% of the patients. So that's really exciting. So that's one of the things that they looked at. The next thing they looked at was the memory cells. A quick reminder, the memory cells will give you the ability, or your immune system, the ability to recognize the infection by this virus later on in your life. So if you were to get infected by the virus later on, it would remember the virus and will build a very strong and robust immune response to the infection. So that's what they measured next. And they did that in two different sort of experiments. One of them is measuring the memory B cells, just one of the memory cell compartments. And what they saw is that the memory B cells, there was a robust increase through the first 120 days of the monitoring phase. And not only was the increase quite robust, but actually it stayed high. It sort of leveled off and stayed quite high. So this means that not only did you create an immunity, but you actually, the memory cells, the memory immunity, it stays in the patients, and it lasts as long as 6 to 8 months into the study. And the last sort of thing that they monitored that I want to share with you is actually the memory T cells. So the memory T cells, also another component of the memory immune response. The T cells, same thing. They not only did they increase throughout the study, throughout the 8 months of monitoring, but it stayed relatively high. It actually dipped a little towards the end of the monitoring time, but the expectation is that it's going to the memory T cell level is probably going to plateau. And the reason why they expect to see a plateau of the memory T cells is because in other studies, other viral studies of this type, they've seen that usually memory T cells sort of respond in this way. They increase throughout the time post-infection, they dip a little bit, and they sort of plateau. So that's the expectation. And as soon as we get an update on this sort of study, maybe a couple months from now, we'll be able to see that. So super exciting. They not only have an immune response, these patients, but they actually have the immune response, the immunity stays, and it's quite strong 6-8 months into the monitoring time. So 8 months after they've been infected. Super exciting. Interestingly enough, there's a study that's going on in the UK that has quite a few patients. It's got over 6,000 patients, where they actually, same thing, they're sort of following up or monitoring people that have been infected by the virus. And one thing that I can tell you is that 5 months, now this study has only been going for 5 months, 5 months after the infection, these patients are actually less likely to get reinfected. So about 83% protection from reinfection again by the virus. So super exciting study. Also a bigger study, but a little bit of a shorter study, only 5 months. These studies are again ongoing, so we'll get more updates from these scientific groups as time goes on. So how can we use these studies to hypothesize the longevity of the immunity that is given to a person that received a COVID-19 vaccine? One thing that you have to keep in mind is that the patients received or were infected by the full virus. Now, the vaccines are usually made with a very small portion of the virus. So what does that mean? It means that, or it can mean that the patient is making antibodies against the entire virus in the case when they're infected by the virus. And in the case of the vaccination, they're actually making antibodies to only a small portion of the virus. But when you look more in depth at the study that I just broke down for you, the antibodies that they looked at, that they measured, were actually antibodies that recognize the same protein that the vaccines are built against. So you would expect to see the same levels of antibodies and the same longevity or lifespan of those antibodies in patients that were infected by the virus and in patients that received the vaccine. So hopefully, as we go forward and monitoring patients that receive the vaccine, we will see the similar time longevity of immunity by the vaccine as we did in the patients, and even more. One thing that I wanted to point out about this study is that the investigators saw a lot of variation from one patient to the other. What does this mean? They all developed immunity and they all developed long-lasting immunity, but they saw different levels of immunity. Some people had high levels of antibody, for example, and some people had lower levels of antibody. So in general, what does this mean? Well, it may not mean anything other than the population is varied, right? We're all different and we may just respond differently to the virus. Interestingly, there's a hypothesis about viral load, meaning that when you get infected, if you get lots of particles of the virus, you may actually develop a more severe disease. And the opposite is also true. If when you get infected, you get exposed to lower amounts of virus, then you may develop a milder disease. So this may also cause some variation. Now, how does this apply to the vaccine? Well, in the case of the vaccine, although it's a controlled amount of vaccine that you're giving the person receiving the vaccine, and you may see a little bit less of a variation, I think at the end of the day, you still will see variation because we're different, right? We will have different responses to the virus. We will have different responses to the vaccine. So what does this mean for people receiving the vaccine? It probably means that if you get a high immunity, thanks to the vaccine, that you're probably not going to be reinfected later, not as likely as somebody that has a lower immune response to the vaccine. And even those that have a little bit of a lower immune response, if they were to get infected down the road, probably the symptoms will be a little bit milder. And we know this because in the population, it's happening, meaning there are people that got infected by the virus, developed COVID, recuperated, and later on they got reinfected by the virus. And in those people, the disease actually was quite mild, and sometimes you didn't even have any symptoms. So what does this mean? It means that when they probably means that when they first got infected, they've developed some level of immunity, maybe not very strong, and that's why they got reinfected and saw some symptoms. But at the end of the day, they build enough immunity that the disease did not develop into something very aggressive or severe. And that's what we expect also from the vaccine. Even if your response to the vaccine is not super, super strong, you will be protected against future infections and protected against the development of the disease severity, if you will. Now, keep in mind that if you are vaccinated and you do get infected, you carry virus. So you could potentially infect somebody else. So always keep that in the back of your mind. Thank you for watching the video. If you're interested in reading more about this study, I will put a link of the paper in the description of this video. So if you're into the science and you'd like to read it, you'll find a link there. Again, thank you so much for watching. Hopefully you enjoyed this video and you found it useful. If you'd like to give us a thumbs up. If you don't, thumbs down it is, and be sure to leave any comments or any questions in the comment section, and share the video with people that might be interested in this topic. You can even have them or yourself subscribe to our channel. In general, the goal for us is to share as much of the science behind some of these discoveries and help you make better decisions about your health. So we'll see you in the next video. Bye-bye.